Everyone, welcome to my new programming club. Today we will be solving another daily Leetcode challenge. Minimum number of tabs to open to water a garden. There is one dimensional garden on x-axis. The garden starts from the point 0 and ends at point n. The length of the garden is n. So this is the garden. It is starting from 0 and going till n here is 5. You can see here also in this example, and here is 5, so it's going to 5. Also, given an integer array, also it is stated that among on all these n positions and on the origin also, there is one tab located on each of these positions from 0 to n. And given an integer n and an integer array ranges, where range means that each element in range indicates that this tab can water a range of I minus range or I to I plus range. So what this means is, for example, let's say we consider the tab at let's have this example as our example, and let me quickly copy it to the another slide. So these are the ranges, and let's mark the indices 1, 2, 3, 4, 5. These indices will be nothing but the positions on the number line 0, 1, 2. Now first range is of 3. Now for index for position 0, we can go till 3 positions on left hand side or 3 positions on right hand side. Our garden will be starting from here to here, as you can also in the description. Then garden starts at the point 0 and end at the point n. So n here is 5. So this will be our garden. Now at each of these positions, there is a tab. And for the 0th one, you can go three distance to left hand side or 3 distance to right hand side. This will be for the 0th position. As you can see in the example, this also. This is for the 0th one. Let me change the color. -3 to 3. You can see the color coding is also same. So this is the area that the tap at the 0th position can irrigate or say water. So this is what this range array is showing to you. And then you are asked to return the number of minimum taps that you should open to water the whole garden. The garden cannot, if the garden cannot be watered by opening all of the taps, then you have to return -1 basically. So one thing is to be noted here is, if let's say the ranges are 0, It means that, let's take this example. Let's mark the indices 0, 1, 2, 3. 0, 1, 2, and 3. So for the position 0, the range is 0, so the tap will not be watering any position. And similarly for all the taps, the range is 0, so the tap is not watering any position. So in this case, we will return -1. Since even if we open all the tabs, it's not possible to water the whole garden. This is our garden from 0 to n. For all the ranges with 0 value, we will be skipping those ranges. Those ranges will not contribute to the answer anyways. So answer will be -1 here. So how you will be solving this problem? Let's consider a brute force way to solve this problem. What you can do is, uh, you can generate the sequences of tabs that you can open at sequences of position of tabs that you can open. Let's say I decide to open 0 position tab, tab 1 position tab, and 3 position tab in a when the garden is starting from 0 to, let's say, 5. So this is one configuration. Now let's say I decide to open only tab at 2 position. So in this way you can generate the combinations of tab openings. So for each tab there will be 2 options for each tab. Let me quickly change the color. For each tab, 2 options will be there. Either to include it in the final combination, exclude it from the final combination. So in total, 2 into 2 into 2 into 2 will go until 2 raised to power n. So n, let's have a look at the constants. N here is 10 raised to power 4, which is pretty high. So 2 raised to power 10 raised to power 4 will be greater than 10 raised to power 8 operation limit. Basically, if the number of operations of your program the solution exceeds or become equal to these 10 raised to power 8 operations which are allowed in 1 second, then you may get a TLE and your solution will not be accepted. So here, those of you who are not familiar with this concept, I will be providing a link of an article describing how the time complexity of a separate solution varies according to input size. So you can check this article and then you will be understand why this limit is being used. So we have to optimize our brute force anyways. Now how you will be optimizing the brute force? Let's consider two taps at 0 position and 1 position, or let's say consider 3 taps. Now this third one, let me give it a color. Let's say it's denoted by color yellow. Now let's say third one is having range from, let's say range something like this, and other two are having blue and red ranges. Let's say 0 is having some range something like this, and this blue one is also having range, let's say like this. So as you can see, if we open the third tab, then if we open third tab, then all these tabs will be covered. So these two, 0 and 1 will be covered since they are already covered in the range of 3. So how you will be checking which steps are covered in uh, which range and they are not required to be turned on. So what you will do is you will check what is the leftmost position 3 can voter. Let's call this X, leftmost position. At garden 3 can voter. Now garden is starting from 0. So all of the positions lesser than 0 will not be our will not be our interest. We will at max the position leftmost position should have a minimum value of 0. So for now let's consider it beyond 0, but you have to consider from 0 minimum. So the leftmost position 3 can voter, then all the tabs, and we will check for the rightmost position 3 can voter. Let's call this X dash rightmost position. Three is nothing but tab at position 3. So if we start from this leftmost position and iterate till the rightmost position that 3 can voter, all the tabs that are coming in our way will not be considered uh, to be opened because they are already covered. So I hope you are able to understand. So we will have a variable called tab count. Tab count will not be incremented because of these two tabs, 0 and 1. 3 is already covering them, so we will not be including them. So for each tab, we will check what is the leftmost position it can voter, and for that leftmost position, we will let me write it down. For each tap, check the leftmost position. It can water, and at each position, a garden. Store the value. Basically, at this leftmost position, you will be storing the value of the rightmost position that a tap extending its range till this point can water. At this position, storing what is the, let me change the color. What is the maximum position a tap can water? That's right. Is having, let me erase this. This is one and the same thing, so I'm writing here instead. Having left range till this left leftmost, or let's call this x, till x. For every tab that is having its leftmost range till x, we will store the what is the maximum value from this particular x position we can reach in the right direction, uh, that can be voted. So I hope you are able to understand. Let's say after 3, uh, let's say initially this position, let me quickly take another slide. Let's say 3 was here, 1 is here. Now let's say 1 is having 0 range, it cannot water anywhere. Now let's say 2 is also having 0 range. Now let's say 4 is there, and 4 can, let's say, water up to 7, and 3 can, let's say, water up to, let's say, 8. So what is the leftmost position that can be achieved? We will be checking for that. So let's say initially this position is having a range of 3, let's say 7 on the right hand side. Now there comes a tab which is having this as the left boundary or leftmost position it can water, and it in right direction it can water up to, let's say, 8. Then you will update this value stored at this particular position. So let's say 4 was there, and 4 was able to water a area of this area. And let's say 3 was here, and 3 was able to water only this much area. Let's say it was able to water up till here. So we will store the maximum value that can be reached. So at position 1, we will store 8. So I hope you are able to understand. Instead of this 5 value, we will be storing 8. So this is how we will be checking if, and since when we will be at the first position, check what is the maximum range till which we can go. And all those uh, tabs which are covered in this range will not be incrementing our tab count. So more will be clear to you in the coding part. Now let's dive into the coding part. At each position, this new range is array. We will be storing what is the max position, what's right, which can be voted by a tab that is having left limit. Left limit is the leftmost position it can voter, that is having left limit as the current position. So I hope you are able to understand. Uh, if the range is if the range of a tab is 0, we will not be considering it. If the range of the tab is 0, discard it. And we will be checking the left and right limits on the number line that a tab can water. We will be checking left and right limits that a tab can water. So left limit will be considered at least 0 because the garden size is starting from as the garden is starting from 0. And this is because we are taking minimum because as the garden is ending at 0. So pardon me if some spelling is incorrect. I hope it does not affect your understanding of the approach. So what we will do is for the position which is equal to left limit of the current tab, we will store the maximum value, maximum right position value that can be voted. So this will form our new ranges, and then what we will do is uh, we will check what is the current rightmost app that can be voted. Actually, the last step that can be that is covered is 0. So we are checking going from this position, particular position, how many tabs we can cover. So the last step that can be covered, rightmost step that can be covered is initially 0. So as long as we will be starting another count to check starting from current position, what is the farthest or say rightmost tab that can be reached. Tab or say position of tab. So from the we will be updating our current last tab that can be covered as long as our position is included in our last tab that can be covered. So this is basically this logic. As long as we are in the boundary of this x dash, we will be excluding all the tabs that are not contributing to our tab count. So this blue and red one will be discarded. So I hope you are able to understand. So this is for discarding the tabs which are need. This is for discarding tabs which are not contributing to tab count. Basically, we are forming segments. So for each segment formed, we will increase our tab count. For each segment formed, we will increase tab count. So if the current last tab that can be covered is now also similar is equal to still equal to the previous last tab that could have been covered, then you will immediately know that not every position button can be voted. In this case, you will return -1. So at last, you will be updating your last tab that can be covered, updating the value of last tab that can be covered. We are not updating this last tab's value along the way because we are interested in discarding the tabs greedily discarding the tabs which are need not to be opened. Greedily discarding the tabs which are not required to be opened. At last, we will return our tab count. So now it's clear to you. I know that in the explanation part here, it was not pretty much clear, but I think here it would have been very much clear to you. If you are still having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer them. The code will be available in both of the languages, C++ and Java. So thank you for watching. Thanks.